In this video, we'll look at a few specialized data structures in Python, dictionaries, and sets. We'll start with dictionaries, but let's take a step back first and think about lists. I'll make a quick list here, my list, with the values A, B, and C. Looking at this list, we know that my list at index 0 will give us a value of A, and we know that my list at an index of 1 will give us B. Lists use integers as indices to access the internal values. Dictionaries are like lists, except they can be indexed with any type. We can create an empty dictionary by using curly braces. My dict equals empty curly braces. Then we can start adding pairs of keys and values to it by indexing. Let's use this to model a bike for sale, so we'll create a key called name, and the value will be a string with the name of the bike. We do that by taking the dictionary and indexing it, but putting a string within the square brackets. We're looking at name, and we'll set that equal to CAD 12105. You can see this looks just like indexing a list, except we're using the string name instead of an integer. Let's also set the price. This time we'll use the key price, and we'll use the value 2000. We can print out individual values of this dictionary by indexing again, or we can just print out the whole thing. This format for the whole dictionary can actually be used for constructing it as well. So that's inside a pair of curly braces. We have a list separated by commas, and each one is a pair of a key to a value. If I do this and make a second dictionary, but then I'll copy and paste this here and print it out, you can see this constructs the exact same dictionary that we constructed previously. We can loop over the dictionary using a for loop. For A in my dict, let's print A and my dict at A. This assigns A to be the keys, and then we can access the values by indexing. Dictionaries are good when you have multiple variables that are related in some way, and the dictionary can sort of tie them together. They're also useful if you make a function that needs a lot of inputs. Instead of having to write out a function with a dozen different arguments, you can just pack them all into one dictionary. Now we'll move on to sets. Sets are different in that they don't support indexing, and they can't have duplicates. You can create an empty set like this. My set equals set, then parentheses. Or you can use curly braces to give it some initial values. My set 2, I'll say this is 1, 2, and 3. Both dictionaries and sets use curly braces, but in a set we don't have the colons to define pairs of keys and values. First of all, note that we cannot do indexing. If I do my set 2, it's going to say that set object does not support indexing. So the main way of interacting with sets is through add, remove, and in. The add function adds a value to a set. So we can take my set 2 and add the value of 4 to that, and then print it out. Now it has the values of 1, 2, and 3 from before, and we've added 4. If we try to add a value that's already in the list, it won't add another copy, it'll just do nothing. Removing works in the same way. My set2.remove 2 will get rid of the value we want to get rid of. Then we can check if a value is in the set with an if statement. If 1 in my set2, we can print something out. And since 1 is in the set, we print that out. There are some situations where a set's lack of duplicates can come in handy, but the biggest benefit of sets is their speed. They're super fast at adding, removing, and doing this in. So if you find yourself in a situation where you don't really need indexing or duplicates, a set will really speed up your code. Dictionaries and sets are more specialized for their particular purposes, but it's good to keep them in mind so that you can pull them out when appropriate.